Okay, yes, it does track. Okay. All right, so we talked about sine and cosine yesterday, and we got the general gist of them, and we talked about the parent function graph of them, and we graphed two pretty simple ones yesterday. So let's kind of dissect those a little bit. So grab your pen, and we're going to make some notes as we go down this page, okay? These are standard form of the sine, cosine, and cosine graphs. They're called sinusoid graphs, which sounds kind of weird and sounds kind of medical, but it's not, okay? A, B, C, D are constants, which means that they are numbers that don't change. And A and B cannot be 0, because if I put a 0 right here, it cancels the whole equation out, and if I put a 0 right there, it cancels the part of the equation out that I would need to graph, okay? So C and D can be 0, all right? Okay, we talked about this word yesterday. The amplitude is half of the height of the wave. So when we were doing the mountains yesterday for sine graph, remember our sine graph looked like this, okay? This is going to be your A. How tall the mountain is or how deep the valley is. It is not negative. Okay, when you're talking about height or distance, it's always positive. Okay, so that's why the absolute value is there, but if you can just remember it, you don't have to think absolute value. Okay? Now, the period we also talked about yesterday. Period is one full cycle. So a mountain and a valley, if you're looking at a sine graph, or if you're looking at cosine, it's peak to peak or valley to valley. Okay? The formula for that is 2 pi over b. Okay? Now, it's 2 pi for the parent function. But if I put a number inside there with the x, it's going to change it. Okay? We're going to talk about that today. The frequency is the number of wavelengths that we get over a certain unit cycle, unit interval. Okay? We don't talk about this as much, but just so you know, it's the flip of the period. Do you see that in the equations? Okay. And then a phase shift is moving the graph left or right. Okay? We talked about this yesterday because you guys graphed one. If I do a plus or minus d, what's that going to do to my graph? Move it which direction? Up or down. Okay? This C and this B are going to move it left and right. Okay? And remember, anything done to the x is opposite. So if I have plus something, it's really going left. Okay? If I have minus something, it's really going right. Okay? You're going to really see why that's the truth in these graphs. Okay? All right, so let's dissect sine a little bit. So turn your page. We talked about this yesterday. Who remembers what's the domain of sine? All real numbers. What's the range of sine? -1 to 1. Okay. Now, we also talked about this yesterday because we looked at one that had a 2 right there. What did that do if I put a 2 right there? It didn't move it left, not right here. It stretched it up. So if A is bigger than 1, that is a vertical stretch. And then if A is less than 1, what's it do? If A was 1/2, what's it do? Compresses it. It shrinks the mountain. So it's a vertical compression. Okay. Now, we also talked about this too. What's that A do? If it's negative, it flips it over, right? So my normal sine graph, let's graph the normal sine graph right here. The normal sine curve looks like this, and then it keeps going left this way. So that's the normal sine graph. We did that yesterday. Okay, about half of y'all had that one as your graph. Okay. So if we did the negative version of that, it would look like this. Everywhere there was a mountain is now a valley, and everywhere there was a valley is now a mountain. I didn't do those last few dots very well, but yeah, we'll try that again. There. Okay, so that would be the negative version. Okay. Now, here's how I graph every single one of these. And actually, Miss Stryker showed me this trick, and it's amazing. Yeah, did you know Miss Stryker used to teach math? She does. Okay. So this is the pattern we are going to write every time we do a sine graph. Okay, and here's the pattern. Root, because this is a root, right? Sits on the x-axis. Up, root, down, root. Root, up, root, down, root. Okay? Here's where those things occur every time. 0, pi over 2, pi, 3 pi over 2, and 2 pi. That's how yesterday when I was graphing these, I could graph them so quick. Because I know the pattern. Root, up, root, down, root. Okay, and it goes by halves. 1, or 0, half a pi, 1, 1 and a half, 2. Okay? So when you do your sine graphs, which we're going to do 2 of them over here, okay, we're going to start with this pattern. Root, up, root, down, root. And then we're going to adjust it as needed. Okay? All right, so let's look at, anybody have any questions about this before we try one? Yes?
So, are the actual numbers that you, the 0, pi over 2, are those with the negative a? Is that what you're doing?
Well, so what would happen with negative a? I would still start with a root, but instead, where would I go instead of up? I would go down. So if I graph the negative version of this, all it does is flip my arrows over.
Okay. And it flips those?
No, it doesn't flip these. All of these stay the same. The arrows just flip. Okay? Okay, turn the page, and we're going to do example 1 and 2. Turn the page real quick before we talk about cosine. Okay, turn the page, and we're going to do example 1 and 2 together. Okay? All right, let's name A, B, C, and D for y equals 2 sine x. What's A in this equation? 2. What's B? 1. It's the number in front of the x. Okay, and it doesn't have one. What about C or D? 0. There's nothing being added or subtracted. Remember, C and D are the add and subtract. Okay? Okay, so what's the period? 2 pi. The formula for period is 2 pi over b. What's our b? 1. 1. So our period is 2 pi. Okay? Has not changed. Our period is still 2 pi.
So your period is only different when b is not 1.
Yep, so we're going to get that one right here. Okay? Okay, so here's how I graph these every time, y'all. I do my patterns. Let me move this one here. I do root, up, root, down, root. 0, pi over 2, pi, 3 pi over 2, 2 pi. Okay? Now, when we go to do cosine, and when we do every single graph this unit, these numbers are not going to change that I'm starting with. The 0, pi over 2, pi, so you're not memorizing anything. They're the same for all of them. Okay? Now, on my little graph, or on my little cheat chart, that's what I call this thing, a little cheat chart, I'm going up how much? 2. So if you need to make a little note to self, I'm going to start with a root here at 0, but then when I go to pi over 2, I now have to go up 2. Okay? Then I have a root at pi, and then at 3 pi over 2, I got to go down 2. And then I go back to 2 pi. Okay? Now, can you finish the pattern over on the negative side? Okay, you do the pattern on the negative side. I'm marking. Now, make sure that you draw some little arrows on the ends. What's funny? Oh, okay. Make sure you draw some arrows on the end because that graph does keep going if we were to extend it. Okay? Is everybody okay with that? Anybody have any question? Okay. Go down to number 2. And with your table partner, I want you to answer all of these parts. A, B, C, D, and the period. And then I want you to draw your cheat chart, and then we're going to fix it.
what does B change again?
B changes the period.
So it'd be,
So that means
so it'd
that,
be pi instead of 2 pi?
no, think about that. It's 2 pi over 1/2. What is 2 divided by half? No.
Or
How many halves are in 2?
4.
4. Yeah. I hate the way that they teach y'all to divide fractions in elementary school for that reason. Because as soon as I changed the question and I said how many halves are in 2, you answered it like that. But you doing 2 divided by 1/2, it messes with your brain. The B? The B is just 1/2.
Well, yeah.
Are you talking about to do this?
Yeah.
Okay. All right. Yep. Okay, so let's talk about what's A? -1. B is 1/2. C, we don't have anything. 0. D is 0. Okay. So I had a couple questions about the period. I'm going to jump this up a little bit. Okay. So the period is 2 pi over B. Okay. Now, because I'm recording, I'm going to ask you to pause and think about what 2 divided by 1/2 is, because I hear 1 shouted out all the time, and that is not true. Okay. 2 divided by 1/2 is what? 4. Okay. 4 pi. Okay, so let's talk about what that means. Okay. Do you see how from 0 to 2 pi I have 1 full wave? What this means is that it takes 0 to 4 pi to get a whole wave. So it's stretched out. Okay? It is stretched out. So let's do the cheat chart and see why that is. Okay? No, it's not squished. It's just stretched out.
But that's inside the bracket.
That's it. Yeah, this A is what determines if it's squished or not, and that's still a 1. So it's flipped over, but it's not any taller or shorter. It's just stretched out this way. Okay? All right, let's do the cheat chart. Ready? Root up, root down, root. 0. Pi over 2. Pi. You're going to hear me say this about 35 times over the next 2 days. Okay? Because that cheat chart does not change. The cheat chart does not change. Okay? So, now here's what I want you to think about. This B alters the cheat chart. Okay? Remember when we were talking about if I had x plus 1, that really moved everything which way?
Left.
Left 1. Okay? We do the opposite of what it says. Right? So what's the opposite of 1/2 x? 2. Okay? Okay? So I'm really going to multiply all of these points by 2. Okay? Here's what you're solving. I'll do the first one for you so that you can really see why it is multiplied by 2. If I were to figure out where my new root is, I'm really solving this equation. 1/2 x equals 0. So how do you get rid of the 1/2 over here? Times 2. That's why it's a times 2. Okay? So 0 times 2 is still 0. What's pi over 2 times 2?
Pi.
Pi. What's pi times 2? 2 pi. What's 3 pi over 2 times 2? 6 pi over 2, which is 3 pi. And then 4 pi. Do you see do you see the period now? What's the period from 0 to 4 pi? Okay, so we have a root at 0. Now, I didn't change my cheat chart. What's this A tell me to do? Flip it. So this arrow is now down and this one is up. So I'm going down 1 at pi. I have a root at 2. I'm going up 1 at 3 pi. And I have a root at 4.
Yeah.
Okay? So this one will be going down like that. All right, give me a question or two before we do something different. What's a question? Yes, ma'am.
Can you please explain that again right there?
What? How to solve this?
Like, that was your explanation for why we're multiplying it.
Yeah, because if I were going to solve, so that x is figuring out where these guys are. Where these roots and things are located. Okay? So but mine is now 1/2 x, not x, like it was in this example. Okay? So if I were to solve and figure out what my new x is, how would I get rid of that 1/2? Well, I would divide by 1/2 on both sides, or multiply by 2. Okay, remember, anything done to the x is really the opposite of what it appears to be. So if you say x plus 1, I'm really subtracting 1 from every single x values. Okay? Taylor, did you have something else?
I answered it.
Got it? Okay. All right. Here's what I would like for you to do. I want you to go back to the cosine, so flip backwards one page in your little book, and I want to see if you and your partner, table partner, can fill out the information, put the correct graph on there, and then I want to see if you can do the cheat chart for cosine. Okay? Remember what I told you about the cheat chart. It is 0, pi over 2, pi, 3 pi over 2, and 2 pi for all of them. What goes above them? Roots or arrows for cosine? Does everybody understand what I mean?
Yeah.
Okay, go. I'm going to lay that there. So.
Nope.
Alright, if you are in row 1 or row 3, would you turn around to the people behind you and compare what you have in your chart?
Compare Is it literally just the opposite?
It's different because so the arm is like where it is. So if you look right here at 0, at the root, at pi to the root. So for this one, at the root, where's that one? Macaroni. See, look. See, it starts up, so you go to down. Instead of starting at a root like 0, it starts up at 1. Down arrow, up arrow, root, down. Yeah.
Okay, so what's the cheat chart? Domain and range are the same. These two things are the same. What's the cheat chart? What happens at 0 now? It's an up. Up, root, down, root, up. Okay, so what would change if A is now negative? Where would it go? Down root, up root, down. If A is negative, flipping that graph over. Okay? All right, I would like for you to do number 3, and then I want to talk about 4. Actually, try 4. Try 3 and 4. Okay? Try 3 and 4. Turn the page, because it's over on the next page. If you didn't graph sine, or cosine, you can graph it right here. If you didn't graph it real quick. We did it yesterday a couple of times, but... Okay, try 3 and 4 with your table partner. What? Yeah.
It was easy.
Well, okay, everything was easy except like the 6 questions are all easy.
Okay, so like if there's
But you get half.
I don't know how. I don't know how though.
I mean, 5's and 5. Still
Okay, it's fine.
C.
No, you're gonna pair.
Chris,
But except for the clip.
Yeah, but we still, he always gives us an advantage of 5 over 1.
this work.
The 1/3 switches the way.
Because he knows he's in.
I don't know how to put that up.
Yeah, you do.
Oh,
They're
yeah.
by 3. Yeah. I was nice to you. Hey, notice that I gave you correct tick marks in number 3 to measure your wave height. Yeah, the height is 1/3 and the tick marks are divided by 3.
I didn't do anything. Kind. What's 2 over 1/3?
It'd be two divided by 1. So
Yeah, 2 over
Why?
1.
What are you trying to figure out?
Because when you do period, the 2 pi over 1/3, and then you get.
Period is 2 pi over b.
There's my problem. So it'd just be 1.
B is 1, and so the period is still 2 pi.
said mine. My last name is no, I don't know what I guess.
Do you want me to
Telling
work
me that our Wi-Fi
Everybody wants me to work with them. I don't know why. Jarvis wants me to work with them. That nice one, the big one.
All right, kiddos.
yeah, you gonna have to help because I know.
What? What? Okay, let's start filling in some stuff. A is 1/3. B is 1. The other 2 are 0. We haven't got into shifting left, right, and up, down again. Okay? Period is 2 pi over B or just 2 pi? Yeah? Okay. So 0 pi over 2 pi, 3 pi over 2, 2 pi. Cosine is up, root, down, root, up. How far are my up and downs going? 1/3. So if I start at 0, I go up 1/3, I'm right there. At pi over 2, I have a root. At pi, I'm at negative 1/3. 3 pi over 2 is a root. 2 pi, I'm up 1/3, so it looks like this. And then you should be able to extend your pattern to keep it going, okay? Make sure you put arrows on the end of your graph because it does not stop. Is everybody good with that one? Okay. No? On what? What part?
I just confused by your points.
Okay, they come from right here. They come from the cheat chart that we did.
So you multiply it by 1/3.
No, the 1/3 is just how much the up or down moves. This has not changed because B and C did not change. The only time these points will change is if B and C are different. Okay? And they're not. Okay? Down here it will. Down here it will because there's a B value. Okay, let's do the one on the bottom. A is negative 3, B is 1/2. Again, C and D are 0. What's the period?
4 pi.
4 pi. Okay, 2 pi over 1/2. We talked about that one in the last problem that we did. Okay, so now if we do a cheat chart, I had a feeling that was going to happen. Okay, 0, pi over 2, pi, 3 pi over 2, 2 pi. We are up, root, down, root, up. Okay, this is why I like to have colors. Because that negative up here in front of that 3 means what to all of my arrows? They're going to flip. So down, up, down. Okay, so you'll see me, like, if I put my answer key up here, what I do is that I do the original cheat chart in pencil, and then I go over it in a darker color.
Wait, why did you say they were going, why they flip?
Because of that negative sign right there.
Okay.
Okay? And if you need to make a little note, they're going up and down 3. That's what that A does. Okay? Alright, what does that 1/2 do to all of my points underneath? Multiply them by
2.
2. Yeah, remember it's the opposite. So if I'm timesing by 1/2, then I'm really going to multiply by 2 when I come over here. So 0 is going to stay 0. This one becomes pi. This one becomes 2 pi, 3 pi, and 4 pi. Everybody okay? Okay, so at 0, I'm going down 3. At pi, I have a root. At 2 pi, I'm going up 3. At 3 pi, I have a root. And at 4, I am down 3. Well, that didn't do it all. Okay? Give me a couple questions, because these are the easy ones where I only do like one thing to them. Like where I only have an A, or I adjust the height of them. Now we're going to shift them, and it gets a little bit harder. Okay? Yes, Jacob?
So, you're like figuring out how much you're going up or down, you just look at A, right?
Yep.
Okay.
That's all you do. Look at A. Any other questions before we go and do some harder ones? Okay. All right. I'm going to do number 5 with you, and then you're going to try 6 by yourself. Okay? All right. So we are not going to do this part because we're just going to build our cheat chart so you can actually scratch through that. Okay? Let's answer all of the questions. So what is A? Negative 1/2. What is B? 2. What is C? Pi. And what is D? Negative 1. Okay. That's a lot of stuff. Pi? Okay. All right. So let's build our cheat chart. Yes.
Would it technically be negative pi? Because
It doesn't really matter. I'll show you why it doesn't really matter, because we're going to do it in the cheat chart. And they're not going to ask you what is C on the dual credit test. They're going to ask you how to graph it. Okay? All right, so root up, root down, root, because that one is sine. Pi over 0, pi over 2, pi, 3 pi over 2, 2 pi. Okay, that's the baseline. That's the one we start with every time.
So when you just off the back.
Okay. Okay, so talk to me about that, Cameron. Why would we off the bat just flip them?
It's negative.
Because A is negative. Okay, so Cameron said off the bat flip the arrows. Okay, so we are down 1/2 and we are up 1/2. So there's that. So that takes care of the A.
And times by
Okay?
1/2.
Now, here, remember when I showed you the problem earlier where I wrote out 1/2 x equals 0 to show you why it was a multiply by 2? Okay, essentially that's what we're doing right here. 2x minus pi equals 0. Okay, that's for this one. Okay, so what is x going to be now? Pi over 2. So if I solve for x, I would be adding pi and dividing by 2. So my new spot is at pi over 2. Okay? So do you see what it did?
Yeah.
What did it do? Shifted it which way?
Right.
Right? Pi over 2, right? Okay. Guess what it's going to do to all of these points?
It's just going to move. So
Shift them right, pi over 2. Okay? So,
Every 2 things.
okay, so now let's do another one just to make sure. I always do 2 of them to make sure that I'm correct in my thinking. Okay? So let's see. Because this 2 may do something weird. It may look like that, but it's not. I'm going to do this one because I'm going to avoid the fractions. Okay? Here's why. If I know this point and this point, this one's right in the middle. Right? I don't have to know the exact point, but I know it's got to be in the middle. Okay, so let's solve this one. 2x minus pi equals pi. So 2x equals 2 pi. So what's x? Pi. Okay. So that one's the same. Okay, what's halfway between 1/2 and pi?
3 pi over 4.
3 pi over 4. 3/4. Okay. So do you see how far apart they are all spaced? How far? Yeah, they're a fourth. From 1/2 to 3/4 is a fourth. From 3/4 to 1 is a fourth. So where's this one going to be? This is 1 pi.
5 pi over 4.
5 pi over 4. Okay? Now, if you don't know those numbers, that's okay. Watch what happens, okay? Last thing before we go, we start putting stuff on the graph. What does this do? It doesn't flip it. It moves everything down 1. So here's what I do on my graph. Instead of my x-axis being here, where's it going to be? At -1. So I do a little dotted line there because that's my new x-axis. Okay? That down 1 has shifted the whole graph down. Okay? So now let's start putting our dots on there, because once we get a couple on there, we just do the pattern, right? Okay? So I have a root at pi over 2, but remember my root is on now what is my new x-axis. Okay? I have a down 1/2 at 3 pi over 4.
Why is there the dotted line again?
Because I shifted everything down 1. So I just moved that x-axis down 1. So I knew where to go. You don't have to draw the dotted line. I always do because it helps me keep everything straight.
So where's that 3 pi?
Huh? It's right here. It's in between pi over 4, pi over 2 and pi. I have a root at pi. Okay, and so then my next little tick mark would be an up. I don't really care what that point is. 5 pi over 4, but okay. So then you can just keep with the pattern. So I should have an up here, a down, a root, a down, a root, an up, a root, a down. Once you get a little chunk of the pattern, you can just keep drawing it.
Dope.
Okay, that's the cool thing about these graphs, is you really only need to know about 3 or 4 points in them, because then you just keep drawing. Okay? Does anybody have any questions? I did the super hard one with you. Okay?
Dang.
I would like for you to try 6 with your table partner. So go. Wow, stuck it in my pocket. You don't have markers? Yeah. She does. I'm not going to ask you what she did on it. I just need you to know how to use them. So what are you going to do with all of these numbers underneath here? With this? Instead of subtract pi over 2, what are you going to do? Add pi over 2. Yeah. Yeah.
Oh yeah, you did reset that. Look at negative pi over 2, then it's negative pi over 2. I have one as pi over 2.
Half was add 1 pi. Yeah.
Negative pi.
Yeah. So why don't we put down
You're trying to show your mark.
You're plugging pi over 2. Minus pi over 2.
Yeah.
Zero in there is negative one.
X minus, and I realized I wrote that off up there, so I switched that wrong.
You wouldn't know what to do if you got
Yeah, you really only have to find a couple, because then you can start doing the math. Oh, that's, Hey, kiddos, I realized after I worked this whole problem that I wrote a minus right here and it was supposed to be a plus. So just change your original one to a minus right there and then the graph should be fine. I don't know why I did that. I just transposed it wrong when I was writing it. So just change it to a minus and the graph will be fine.
How does it work now?
What?
The first one.
So at pi over 2, we're going from your new x-axis, we're going up, however much you're supposed to go up. However much you're supposed to go up through a value, which is 1. So go up, no, that's what you're counting by half.
And then you got to shift it up.
They just counting by half.
Yeah.
Yeah, so you go from this is 1 and 2.
So this is my new one.
That's your new x-axis.
Oh my God.
Yeah. Okay, let's talk about this one. Let's talk about this one for just a minute, okay? So I saw a lot of really awesome stuff as I'm walking around, okay? A is 1, that makes it easy. B is 1, and that makes it even easier. C is either negative. I don't want you to get hung up on the negative or the positive version of that. It doesn't matter. I need you to know how to draw it, okay? D is 1. Okay, so I saw a lot of you immediately do this. When you saw that D was 1, you drew a new x-axis up there, which is great, okay? This is a cosine graph, so it's up, root, down, root, up, 0, pi over 2, pi, 3 pi over 2, 2 pi, okay? What does this tell me to do to every single point? Add pi over 2. So 0 plus pi over 2 is pi over 2. Pi over 2 plus pi over 2, or 1/2 plus 1/2 is pi. Half a pi plus half a pi is a whole pi. Okay? A whole pi plus a half is 3 pi over 2. This one's going to be 2 pi. This one's going to be 5 pi over 2. Now really you don't have to keep going, because once you get about 3 points, that's enough to do the pattern. Okay? Now here's where people mess up. At pi over 2, go to your new x-axis and then go up 1. So your point should be there. Okay?
Why would it be up? Well, you already moved up 1.
Yes, because this told me to shift up 1, but then my amplitude is still 1. Okay? I have a root at pi. At 3 pi over 2, I'm going down 1, so that actually puts that point on the x-axis, okay? I have a root at 2 pi, and at 5 pi over 2, I'm back up again. So, you know, this looks like the sine, or cosine graph that we did yesterday, right? And then you just keep doing your pattern. Okay, and it keeps going. So if you can get about 3 points, you're good. Just keep drawing dots. Is everybody okay? Yes, sir. Do you have a question?
Yes.
Okay. What?
I don't understand how you plug in pi over 2, right? It's the x, and then you get 0.
What's the cosine of 0?
I guess it's 0.
What's the What's the cosine of 1? 1 plus 1 is
2.
2. That's why the dot's there. Do you see?
I'd rather do that than do whatever you. I don't understand how you finagled that to make that. How you turn a negative pi over 2 into a positive pi over 2. Add that.
Wait. Where did I turn a negative pi over 2 into a positive? I'm solving this equation.
Well, yeah, but if you plug in pi, right?
You,
Never mind.
are you okay now?
See.
So essentially, Nolan, I'm making a t-chart without making a t-chart. Do you understand that?
Yeah.
Because these are my x values, these are my x values, and these this like up, root, down, root, up, those are the y's.
Yes.
I'm just not writing it as a t-chart. Okay? All right. Let's try a word problem. Yay! Yay, word problem. Okay. This is our last one. All right, here we go. Thank you. One day, all 308 million people in the United States climb up on tables and jump off at t=0. The shock as we hit the Earth's surface starts the whole Earth vibrating in such a way that its surface first moves down from its normal position and then moves up an equal distance above its normal position. Assuming that the amplitude is 50 feet, the displacement of the surface will be a sinusoidal function of time with a period of 54 minutes.
That was a lot.
Wait, would this actually
Okay.
happen?
Sketch the graph showing the displacement versus time, and then write an equation. Okay, so I don't know if it would actually happen like that. Everybody jumps at the same. We might cause an earthquake knowing our area. All right, here we go. You're wasting your homework time by chatting right now. Okay, so at time 0, we are all here. Okay, time 0. No, time 0 is actually at like when you hit the Earth. Okay? And it's saying that displacement is 50 feet going down first, right? Because our pressure would push everything down and then it would come back up again, right? Okay, so we go down 50 feet. So what do you want to count our axis by here? 10?
15.
Why would you count by 15s if you're doing 50? That doesn't make sense.
Cool. It's not what we're going on.
It says right here.
No, by 50.
Oh, by 50, no, 10, 20, 30, 40, 50, okay? Yeah, I just didn't finish labeling. My board is a little out of whack over there. Okay, and then at some point we come back here, like, so at time 0, when we hit the Earth, it displaces it down to 50, and then it pops it back up to normal, and then it comes back up again, so it's creating like a wave.
What is the other?
I don't know what this point is going to be yet, but they told me that it displaces it down and then it displaces it back up again. So my graph is going to look something like this, evenly spaced. Okay? It's going to look something like that. I just got to figure out all of the pieces of the equation. I think I went up 10. 10, 20, 30, 40, 50. Yeah, I'm a little bit high. I'm a little bit high on that one.
only going 30?
It's really not if you count the tick marks.
Oh,
It's just
okay.
off over here on the screen. Some reason this side of my screen does not want to stay calibrated. Okay, so if we're doing a sine graph, it's y equals something sine something, right? Everybody okay? What goes here?
A.
A. Well, what's A?
What?
50. Except, am I going to put 50 right here? Negative 50. Why?
Because it's down.
It went down first. Okay? So negative 50 goes here. I displaced down first. Yeah? Because if I'm doing my sine graph, remember I'm root up, root down, root for a sine. Well, if I need it to go root down, then I've got to make that a negative. Okay? Now, the second part that I've got to figure out is it tells me right here that the period is 54 minutes. Okay? So what's the formula? No, the period's not. What's the formula for period? 2 pi over b. So 2 pi over b equals 54. Why is that important? I need the b for my equation, right? Because I'm not shifting left or right or up or down, but I do have a period and I do have an amplitude. Okay, how do I solve this? Put over 1 and cross multiply. Okay, so 54b equals 2 pi. Now what? Divide by 54. So B equals, now, don't immediately yank that calculator out and start punching stuff in there. Okay, the pi I'm leaving alone. What is 2 over 54 reduced to? 1 over 27, or pi over 27. So my equation is this. Okay?
That wasn't bad.
It's not terrible. No, we're going to practice some of these because they put one like this on the dual credit test that talks about, it actually is a spring, like pulling a spring down and letting it loose, and you know how springs do, like this. So a spring, and they put one on there, and it's not a difficult question. So if I can show y'all how to interpret it and put it into the equation, you should be able to answer it. So we'll do a couple more of these tomorrow, okay? All right. It is now officially time for you to work. You have 2 things you can be working on. The rest of the graphs from the homework sheet I gave you yesterday. Okay? Okay?
I'm just kidding.
Okay. You got 30 minutes. You got a lot of time. Okay? The second thing you can be working on is the spiral review. Okay? So no, I don't help it on spiral review. Okay, if you did problems off your spiral review and you want me to check them, I will be happy to do that during this time as well. Okay? All right, Peyton, will you turn the record button?